In this video, we will solve the following problem. It's asking us how many grams of hydrogen, and notice that this is just hydrogen alone, not the diatomic hydrogen molecule. So hydrogen are present in 5.35 times 10 to the 25 molecules of water. So I'm going to start off by dissecting what the problem is asking us to do, planning out a map for how we're going to solve it. If you feel comfortable on trying that on your own, pause this video, try to dissect it yourself, and then we'll take a look at it. Okay, here we go. So the problem is giving us the number of molecules of water. So we know that we have 5.35 times 10 to the 25 molecules of H2O. And it's asking us to find grams of hydrogen specifically. So just hydrogen, not the entire water molecule. So it looks like I, of course, don't have a direct relationship between the molecules of water and grams of hydrogen, which means we need to find some sort of unifying concept that is going to take us from one to the other. However, as soon as you see the term molecules or atoms or some number of particles, think about Avogadro's number, because we know that Avogadro's number tells us that in 1 mole of anything, 2 times 10 to the 23 of that particular thing. So if you have 1 mole of water, then you have 6.0 molecules of water. And that can take us from molecules of water to moles of water. Once we have that, as soon as you have moles, converting between different substances becomes a lot easier, because if we have, let's map this out. Molecules of water, that's where we're starting. And we just said Avogadro's number can take us into moles of water. As soon as we have that information, we can get to moles of hydrogen. That will be pretty straightforward. That just comes from the subscript in the formula. And that's telling us that for every 1 mole of the water molecule as a whole, we have 2 moles of just hydrogen. So the formula subscript can take us from the moles of the compound into moles of the element. And once we have that, well, then getting to grams of hydrogen is fairly straightforward. As soon as we have moles of hydrogen, we can get to grams of hydrogen using molar mass. So keep in mind that molar mass is expressed in grams per mole. So as soon as you have moles, you can use molar mass to get to grams. And that works for compounds and for elements. So here we want the molar mass of just hydrogen, because all we're asking for is grams of hydrogen. So that is our roadmap here. Let's start calculating some stuff. So it's giving us molecules of water, and it looks like we had 5.35 times 10 to the 25. Okay, so the first thing I want to do is get to moles of water. So we're in this pathway right now. And I need to cancel out the molecules, which means I need molecules to be in the denominator. And we know that there are 6.022 times 10 to the 23 molecules of water in 1 mole of water. And now our molecules of water cancel out, and we have moles of water. So we are now here, and we are trying to get to moles of hydrogen, which means I need the moles of water to cancel out. So I'm going to put 1 mole of water in the denominator, and I'll use this conversion, which is telling me that in 1 mole of water, I have 2 moles of hydrogen. And of course, that just comes from the subscript in the formula. Now, I'm not interested in moles of water, so we can cancel that out, and now we have moles of hydrogen. So we are now here, and we are trying to get to grams of hydrogen. Now, for that, we're going to need the molar mass, and molar mass is given to us on the periodic table. So since I'm trying to cancel out moles, I need to put moles in the denominator, which means that 1 mole of hydrogen is going to weigh 1.008 grams. And I'm just rounding a little bit here so I don't have to write as many digits. Now the moles of hydrogen cancel out and we have grams of hydrogen. And now we can just plug all of that in. So everything in the numerator gets multiplied and you're dividing by the denominator. Keep in mind when you plug this into the calculator to keep the exponent and everything in parentheses in the denominator to make sure it's plugged in correctly. Okay, I am getting 179 grams of hydrogen. And that is all.